The next one we see often. It says that the opposite angles of a cyclic quadrilateral are supplementary. What the word cyclic quadrilateral means is that we have a four-sided figure whose vertices meet on the circumference of the circle. So its points or its corners are on the circumference of a circle. And the property of the shape is that angle A plus angle C is equal to 180 degrees, and angle B plus angle D is equal to 180 degrees. And the statement we make is opposite angles of a cyclic quadrilateral. And remember, even though we are repeating the reason, our statement is not the same statement. In our first statement, we are using angle A and C, and in our second statement, we are using angle D and B. Okay, this is probably the converse which we see the most often. It says that if the opposite angles of a quadrilateral are supplementary, then the quadrilateral is cyclic. What it is saying is if I have a four-sided figure and the opposite angles, so if it is given that A plus C is equal to 180 degrees and B plus D is equal to 180 degrees, then this quadrilateral is a cyclic quadrilateral. So in this diagram, we are given A plus C and B plus D is 180 degrees. Therefore, we can say A, B, C, D is a cyclic quadrilateral. And when we make statements like that or conclusions like this, we need to add a reason to it, like we would with congruency. So we can say the opposite angles of a quadrilateral are supplementary. So then I'm referring to this. The opposite angles of this quadrilateral without the circle is supplementary. Or I can say converse opposite angles of a cyclic quad. Converse refers to the word conversation or discussion. So I have discussed that the opposite angles of a cyclic quadrilateral is 180 degrees. That's when we use converse. The circle was not given, but I've discussed the properties in such a way that the circle can be drawn in. Next up, we have the exterior angle of a cyclic quadrilateral is equal to the interior opposite angles. What we are saying now is that the angle on the outside of a cyclic quadrilateral is equal to the angle on the opposite interior side. What's important to know is that the side of the cyclic quadrilateral BC is extended. It's a straight line. A lot of times people confuse this because they fail to recognize that the line outside of the cyclic quadrilateral is not always a straight line. And then they use this property incorrectly. So make sure that this line or side of the quadrilateral is extended, and then this property is true. So I can say angle A is equal to angle C2, exterior angle of a cyclic quad. And yet again, there's a converse or conclusion or conversation which we can have. So if the exterior angle of a quadrilateral is equal to the interior opposite angle of the quadrilateral, then the quadrilateral is cyclic. So what we are given is that there's an exterior angle. And if we can prove or given that it's equal to the opposite interior angle, then these 4 points lie on the circumference of a circle, and therefore this diagram ABCD or this quadrilateral ABCD is a cyclic quadrilateral. Notice the reason when we make a statement like this. So ABCD is a cyclic quadrilateral. And I can either say the exterior angle is equal to the interior opposite angle. So I'm discussing ABCD from this perspective. That's when I don't use the word or the definition of a cyclic quadrilateral. I simply say exterior angle is equal to the opposite interior angle. Alternatively, I could say converse exterior angle of a cyclic quad. So now I'm discussing ABCD from the perspective of a circle, which is normally not drawn in or not given. And that's when I use the word converse. So I've proven or had a conversation around the exterior angle of a cyclic quadrilateral. Our second last theorem on circles is if two tangents are drawn to a circle from the same point outside of the circle, then they are equal in length. Simply, AB and BC are tangents, and because they come from the same point or produced from the point B, they are tangents from the same point, they are equal in length. And lastly, we have the angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle on the alternative segment. So if I discuss the word tangent, it means a line touching the side of the circle. So in this case, it's touching the circle at point C. And if I produce an angle between that and a chord, then that angle which I produced is equal to the angle on the alternative side of that chord. Also, I can see that angle C1 using those same properties, so chord AC, I produce angle B. So these two would be equal. And then I can say angle A is equal to angle C3 tan chord, and angle B is equal to angle C1 tan chord. Now, in assignments and examinations, you must make both statements, even though it's the same reason, it's referring to different angles. So don't think you can just make that statement and leave the reason out. You need to have a reason there because you can see it's referring to different chords and it's also referring to different sets of angles.